And that way, at least we can get this out to the masses when everybody's good to go. So, hello everybody. Hello, Nick. Nice to meet you.
Nice to meet you as well, gentlemen. Am I doing this right? I've never done this before.
Oh, you're doing just fine. You can put if you don't, we don't generally show our talking heads up there. It takes up too much space. With Jim's head, it takes up way too much space on the screen. I mean, you can if you want.
That's a lot
Man,
better.
But
Chris is beating you up, dude.
Thanks, Grandpa.
hey, anytime, anytime. All right. So today's topic is Robocell. And to start right off, do you guys that are here have any questions on Robocell? Have you all been able to get a chance to at least open it, make sure it works, and see if it runs?
Yeah.
Since
Okay.
since you brought up the problem of licensing, why does the license on this thing fail?
I don't know. I take it right down to my IT guy and said, "Here, fix this." That's how I fix it. That's done. And that's exactly tomorrow morning, 8 o'clock. That'll be on his desk with a note, a sticky note. Here, fix this. And I'll be using my little laptop to solve the problem. Sorry, I'm no help with that.
Just was wondering.
Yeah, and I don't know why it timed out on that laptop because it should be good right through the end of this year. It's got my school license on it. It's as simple as all they do is they reinstall the proper license. They go in and they install the right code and it's good to go. It's just that it's in Jim's, you see, look on Jim's screen, you can see it tells you how many days you have left. And if you don't get that window, then there's a code that came with the software when you when you downloaded it. You received an email. Somebody who received the software received an email, and in the email is a code. You type that code into the window when it asks you for it, and you're good for the rest of the year. This software is generally hassle-free. I have never, ever, ever until just now, 15 minutes ago, had a problem with this software timing out. And that's just, there's got to be an oversight on my part. I must be running the wrong license on it. It's no big deal. But I don't think you'll have an issue. I don't think you guys will have issues if you're using the school license that you got via email.
Like I said, I was just wondering because you had a problem and it was something you knew
No,
about. Then
no, like I said, this is the first time in years that this software has given me any problems. I've had no problems whatsoever with this software. So, hello, Brian. Wow, we had a full house tonight. I actually have to scroll the screen to see everybody here. That's awesome. So, anybody have any questions about RoboCell before we get started, or do you want us to start right from the beginning?
This is Steve Finansky in Columbia. I'm on my first meeting,
Hey, Steve.
and it would be helpful to me to start from the beginning.
Okay, perfect then. Jim, since you've got the screen, you wanna you wanna do the honors?
Sure. Um, Robocell itself is really fairly intuitive. There are a couple little hang-ups about it, but once you kind of learn them, everything goes fairly well. As far as your zooming and manipulating the screen, it works just like it does in CNC Motion. So the wheel on your mouse will tilt your screen. It's the same as the slider bar that's along the side here. Your right mouse button pushed in and out will zoom, and side to side will rotate. So those are your main things to manipulate the environment. So what you're really looking at right now, this is my cell supposedly. The way this software works, excuse me, you're actually broken up into two software packages. You have Cell Setup, which allows me to define the environment everything that's going to be in it, go ahead and do all my pre-wiring, all those types of things, and then you have Robocell itself, which allows me to go ahead and start defining positions and writing the program itself. So you're really looking at two completely separate elements. So we'll just get started. I'm going to come up here to my little new icon or file drop down for new.
And
I'm going to go ahead and use the ER4 because this is the only one that I have a license for. And if any point in time you see me do something that either doesn't make sense or you want me to do it again, just let me know. Otherwise, we'll just go ahead and move on.
let me just,
So ER4.
if we could just step back
Go
for
ahead.
one second, because we've got a bunch of people that are brand new. The workflow that goes along with this, there's a couple of videos on our website that kind of explain it, but basically you have to build a cell, and that's what Jim's in the middle of doing. So you go into cell setup and you build your cell, unless of course it's given to you. And then once your cell is built, you open up Robocell and you get to manipulate the cell. So what Jim's doing right now is, if you take a look on the right-hand side of the screen, he's building that cell that he's going to then program. And kids have a hard time with this. So when you go to open a program, you don't really open it sometimes. You have to import the 3D model. So as Jim's going through this, like you said, if you have any questions, the idea is you make the cell, you make the factory that you're going to be working in, and then you open it up in Robocell and then you program it. So with that, go ahead, Jim, and finish up with the building one.
So in cell setup, all I have defined is what robot is going to be available for me in my folders. So that part can't be undone once the file is created. So once I go to new and I say it's an ER4, that part is static. That part is going to stay for the specific cell. I can now come into robot, and there's only going to be one there that's my option. It's whatever one I selected as my default. When I go ahead and import it, I can either bring it in with a slide base, 1 meter or 1.8 millimeter, or for no slide base. Your first couple activities, the kids are going to use no slide base. So you just say OK, and when it does that, it'll automatically populate the robot right in the middle of the screen at 0, 0. So it's defined right there in the middle. I'm just kind of floating there. Each one of these folders holds a whole bunch of different things that you can put in. You can kind of practice around with a bunch of them, but for right now, all I want is a robot. I want a table, and I want some material for it to play with. So I will go ahead and come to General. And I have this nice little table here built out of what looks like 80/20, and you get to decide how big it's going to be. For this first couple activities, you can just kind of leave that alone.
It seems kind of weird to put the robot out there first, but it's a good point to stress to the kids that everything in the work cell revolves around the robot. So all the coordinates of everything you put in the cell deal with the robot, and the robot base being 0, 0, 0 in your Cartesian coordinate system. So get used to having, like Jim said, put the robot in first, because everything else revolves around it, and then you build the cell around that robot without rotating the robot. If you choose rotate the robot, you mess up the coordinate system of the whole factory. So pull in the robot, leave it there, and then pull the rest of the stuff in.
Your little icons up here, your little blue cylinders, the first one will just show each thing's name. Your XYZ will show their coordinates. The one with the red X on it will allow me to delete objects. And then the one with the little hand on it will allow me to grab objects and move them in some kind of location. You can also double-click an object. It'll give me the option to rotate it. It'll also give me the option to go ahead and put it in as a specific position, whatever it is that I want. One of the things that I want the kids to really start to understand, you have this in your PowerPoints, is before you really start getting into this robot and everything, is them understanding what a robot's work envelope is. So if I double-click the actual robot itself, I've got one that says show its envelope. And once I do that, that will show me everywhere that the robot can reach and can't reach. The bad part is what you got to try and teach the kids is it's an illusion. This ring is based off of how the robot currently is. So if you really take a look at it, he can't actually reach this blue line on the table. It's just an illusion, because its gripper is going to be straight up and down here in a minute, -90 to the table, and if you put something out here at this blue line, it'll say that it's outside of its reach and it can't go get it. It's a good talking point to start getting the kids to think about why we have this Pac-Man shape, and hopefully you can get the kids to kind of start giving you solutions that it has to do with its wiring, that it can't go back in there because of the way that it's wiring, its belts, electrical components that are inside it, and so on. So you can see that it actually can reach farther behind it to the right than it can to the left. All right, so we've got our table, we've got a robot, and now I want some material. I'm just going to grab a cube. Right now, it doesn't matter what material it is, doesn't matter what color it is, and we're just going to leave it as the 40-40-40. I'll say OK, and I'll stick it somewhere on the table, and then I will position that somewhere specific. The bad part, and I still have never really found out why, it's counterintuitive about the X and the Y. If you look at the coordinates as they are right now, and I say that this is going to be 0, we look at that again, Y appears to be my side to side, and X appears to be my in and out, which is not the way most students would think. They think that you're looking at the robot this way, that this should be your Y in and out from the robot, and X should be your side to side. It's not the way that it works. It's not the way they have it developed up. They actually have it developed this way, where you have your positive X or your positive Y over here and your positive X this way, and then you have your negative Y over here and your negative X back into here. Why it's set up this way, I don't know. You could rotate the robot. I've never had the kids do it. Most of them, it's never been a hang-up for them. They just kind of learn eventually that Y is not side to side, Y is in and out, and X is side to side. So it just is kind of what it is.
Yeah,
Anything on that one, Chris?
it's backwards from everything, and we have real robots, and it's, I thought, okay, it's some craptastic software that they just do things backwards in Israel because that's where Intelitech is made, and it's not. It's all Fanix. All these robots that you talk about, X is Y and Y is X, and I've yet to figure out why.
Yes.
It's just the way it is.
Jim, Chris, I can tell you why. You there?
Yep.
Yeah.
This guy. Oh, all right. It has to do with how the robot's actually designed around 6 axes. Most industrial robots are running 6 sets of resolvers there. And in order to get those resolvers to talk to each other and go to a home position, because normally they have a tool center point that they use for home positions, and they test those with. In order to do that, if the robot has a stop on it and you don't do it that way, the robot works in reverse. And so they don't want it working in reverse. They want you to see it one way and have to do it the other so that it doesn't do that. It came from when they first started building these things, and 35 years in the industry, it's kind of I saw them come from the ground up, really, because we didn't have robots like this 35 years ago. They were just building them, and a lot of them would work backwards when we first put them in, literally. So they had to change the X and Y coordinates to, and actually the Z coordinates is different depending on, like, if you had a Kabuto or something that's a real industrial robot, that Kabuto's Z axis works backwards. It goes in and out the opposite direction of what you think. And it has to do with how visually you're doing that with the teach pendant and those resolvers and the stop. Because almost every one of them prevent the 360 turn with a mechanical stop on the back also. So it kind of gets this, it's counterintuitive. I will tell you, as somebody that came through the industry, it is very counterintuitive initially.
Thanks,
but
Scott.
if you learn it, it actually works pretty well for you.
Yeah, kids are flexible. You just tell them X is Y and Y is X. They complain for about 3.5 minutes, and then they go to town. So
yeah, they figure it out easier than we do.
Yeah, exactly. Thanks, Scott.
So with the way the software works, one of the big hang-ups with it is it actually creates multiple files. So one of the files you're going to create is the 3DC. So one of the things you're going to really want the students to do is get extremely organized with how they build each one of their cells. So I've just called this PDP cell 1. I'm going to store this in a folder all by itself. And you're going to see here in a minute there's going to be multiple folders, or multiple icons are going to populate into the same folder. So we'll go ahead and hit save. Once I've hit save, I'm really done with cell setup, and I can go ahead and completely close out of it. or I can just go ahead and come over here. So I'm just going to start a new program, and like Chris said, this is where you get to play with the robot. So this is really my teach pendant simulation component. So what I'm going to have to do is I'm going to have to import my 3D, and the 3D model I have right now I just threw up on the desktop, and there it is. So go ahead and say open, and now I have this one specific cell. I will tell you, however this one is, whatever view it's looking at, those types of things, when it gets saved, let's make something happen and I'll resave it. When I come back into here and I reset my cell, it's whatever it was. So if you don't like the image, you can change the image in the cell setup, or I can manipulate it in here, because you'll find you'll get one picture exactly like you want it, or exactly where the gripper is. You've got it tilted the way you want, and every time you hit reset, it will keep jumping to somewhere else, and the kids can't figure out why it keeps doing that. Well, it has to do with however you left it in cell setup, unless I get this one set up exactly the way that I want, tilt, pan, do whatever, and then I have this little 80s camcorder with a floppy disk there. The kids don't know what either one of those icons are, but whatever, it's supposed to be a camera, and as soon as I hit that, now whenever I hit reset, it will save whatever picture it is I currently have. So that's one of the first things. Get the kids to get it kind of like they want and save the camera. So now it will, every time I reset the cell, every time I pick it up and play around with it, whatever, it will keep coming back to here. The next thing is I'm going to come up to Window, and I'm going to pick one of these presets that has to do with how it kind of defines these workspace environments. So you've got the Run screen, which you lose some of your tools. You've got Teach and Edit, which you lose the 3D. You've got Project screen. Simulate and Teach, majority of the time, is what I do. And it'll be the same thing. Once you have that the way you want, you can hit Save User Screen. And now every time I exit this file and come back, it will re-import the 3D model for me. Everything will be just like I see it. I usually have the kids come in. As soon as they drop in the model, they simulate and teach and then save that one. So it's only for this specific file, but it will save this screen however I have it set up. So that in a nutshell is just how to get from cell setup into Robocell. You create your new. Once you have your new, you're going to import the 3D model. You get the camera like it is that you want it. We'll save the camera, and then we will manipulate what the screen looks like and then save that. So that's just a habit that I have the kids get into, just kind of a set of norms that I have them do each time when they come into Robocell. Another window that the kids are going to want a lot, if I go to View, and I've got Robot Movement, this little box will pop up, and a lot of students do really well with this box rather than this one. They have a hard time knowing that the base here is joint 1, then we got joint 2, joint 3, 4, 5, 6, 7, and 8. I don't have yet right now because I don't have that defined in my cell setup. You also have your XYZ movements, which we're going to do linear movements on the X, the Y, or the Z, where it's moving multiple joints at the same time. If you really want to teach them advantages and disadvantages of joint movements and XYZ movements, especially because this robot does not have yaw. This robot only has roll and pitch and does not have the capability of being able to shift from side to side. So a lot of times the Y movements for this robot, side to side movements for this robot, it kind of has a hard time trying to stay perpendicular to whatever it is you're asking it to because it doesn't have that degree of freedom. First thing I want to do is there is a whole set of projects. So if we look at the projects that we've got, there's a whole slew of them, and we're just going to kind of touch on a little bit of them today. So I'll go into Introduction to Robotics and Automation. You have one that's just a pick and place. You have one that is actually physically teaching specific positions. You have stacking and then defining roll angles with a little bit of basic trig. You have using relative or incremental positions, just like they were kind of in CNC motion. We've got arcs that we do. you've got variable programming, inputs and outputs, and then handshaking is where we're going to have the robots communicating with the mill, and they will communicate back and forth with each other. Nice part is you do have in the curriculum, you have them all. So if I go to my downloads, there's actually a folder in the curriculum that you can grab called Scorebot Activities, blah, 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 and inside there you have every single one of them, both in Student Edition and the Teacher Edition. So in Pick and Place, I can give them the full program, or I could give them, if I was just trying to shorten time, I could give them just the 3DC, and they could go from there. You could give them just the points, and they could go from there. So if all you wanted them to do was record programs, it's really whatever you have time for. So you can kind of see that 4 icons are what you're going to get when you've got one complete file. You already know the 3DC is our environment. The PNT is the actual recorded points. The SPB is your program, and the WS is the package that puts all of this together. So I've got the 3D image, I have all the coordinates that I'm going to record, I've got the physical program, and then I've got the piece that compiles all those together. Okay, so for the manual movement, I do this with the kids. I don't have them open up the activity. I don't pass out the document. I just have them kind of do this with me, because this is real world. This is how the robot is moved in real life. So I can, right here, I can open the gripper. Kids will also see the icon is up here. These icons up here actually write the program. These icons down here just manipulate what the cell looks like. So I can go ahead and open up my gripper, and I can manually just move the robot down until it's somewhere around the block. They can do it again as XYZs and joints. You just want to kind of get them to start practicing a little bit, trying to figure out what does what. So if I move that and I move this one here, and then I can tilt that there. And oh, so if I come over here to XYZ, I can drop straight down on the Z. I can change my speeds. These are percentages. So this is 100% of how fast the robot moves. And in one way or another, I want to get myself to a place where I'm ready to pick up my block. Majority of the time, I actually have the students work backwards. I have them go down to the table first, wherever it is that they want to pick it up, and that becomes their position. Recording the ones above it is fairly easy. So getting this one exactly where I want, that's the one that I spend a little bit of time with, whether I'm adjusting my pitch, whether I'm adjusting my roll, and you have to go through and you have to teach them what pitch and roll and yaw are. They don't know those. So I figure out that that's going to be a good position. I look at it, I'm centered on the block, and I go ahead and bring up my little record box. I'm going to say that this right now is going to be the position 1. And I will hit this little blue robot, which will record it. Now that position's recorded, that's something that I can physically utilize in my program.
And notice,
so I will close the gripper.
You want to be really clear with the kids, too. Right now, you're not writing a program. They think they're programming right now when they start out. They're not programming yet. They're just moving. It's playtime. They're playing around with the robot in the simulator. So the idea is that you build your cell, you bring it into Robocell, you teach all the positions, and once you've taught all the positions or recorded all the positions, you can then go write your program. So there's the next step in the logical order.
So now what I'm going to do is just pull the robot up in the air about the height of a block. So that's good enough, and I will call that position 10, and I will record that. Now all I ask them to do is I ask them to bring another position over here and then another one over here. So they just have some multiple places that they're dropping it off. It's going to get grinded over here or something. The robot will go back to its home position and come back and get it and take it over to get painted, whatever. So they're learning how to manipulate the robot, learning how to move it around, learning what each one of these joints and everything do. In the activity, it just asks them to pick it up, bring it back, put it right back down. And I have found in the past that does not provide them enough practice to be good at it to do the rest of them. So, put 4 or 5 points, put 2 or 3 points. You got a kid that's all completely done, make them do a couple more. Make them put another cube on the table and make them go get it somehow. So I'm just going to kind of rotate on my base. So I'll say I'm going to have a position over here, and that will be my position 20, and I'm going to record that. And then down, if this was real life, I'd be laying on the floor, being right underneath the table, trying to eyeball it to see if this is going to go exactly where I want, because right now I'm not going to be teaching positions, I'm just manipulating it. So it's really nice in the software where you can just drive it down until it hits the table. Once I hit the table, and that's my position, I can record that as 2. You see, I haven't actually let go of the cube yet. It all has to do with actually being able to get it and some of the problems that I'll run into later on. But right now, I'm just kind of manipulating it. And let's go back to 20. This little icon right here will allow me to jump 2 positions. So I'll do that. So it goes back to 20, and then I'm just going to do one more movement. Oops. And we'll bring him over here somewhere. That'll be my 30. And then run it back into the table again. So I have positions, I've got my pickup positions, I've got some drop-off positions and so on. The thing I don't have right now is I don't have a home, a comfortable position for the robot to sit at in between each one of these operations. Majority of the time, you just have the kids hit reset, and that is going to be its home position. What you can't see is in real life, there's actually some rubber bumpers back here. This is supposed to be the most centered or the most comfortable robot that the comfortable position the robot can sit in. It takes all the stress and strain off of its motors. These aren't servo motors, so it really isn't that big a deal. But for the most part, this is supposed to be its natural position. So I'll call that my 99, and that's just typically what we call our home. So if I look right now, I have a 99. The 1 was at the table, 10 is in the air, 2 is at the table, 20 is in the air, 3 is at the table, 30 is in the air. You can really do whatever rhyme or reason for your programming kind of makes sense to you. This is really back a long time ago when I used to do handwriting code. It has to do with being able to insert numbers. If I need an extra position somewhere in here, I've got I've got a couple other positions, 11, 12, 13, 14, 15, 16, and so on. So I'm going to now go ahead and start running my program. So I don't need you anymore, I don't need you anymore, and I don't need you anymore. But I do need you in my life. So over here, this is where I'm going to start writing my program. This is where my icons to write. Eventually, this is what you're going to use, and you'll see that you have a ton of commands that in one way or another can be used.
Hey,
But for
Jim,
these first activities, I don't even show those to the kids.
show them though too that make sure you're not in level 1 or level 2. If you want all of the tools, you have to be in the pro level. Perfect. Because kids will open up, we call it loser level 1. The kids call it loser level 1 or loser level 2 or pro. And if you're in level 1 or level 2, the tools that you have available to you aren't as many as if you're in pro mode. So if you're missing tools, make sure you're in pro mode and all your tools will be there.
Other big thing is if the robot comes in and looks like this, where the robot is straight out, it's in online mode. It's actually trying to communicate with the controller box. So if your robot looks like it's not going to do it, but if it looks straight up and straight out like it did back in Cell Setup, a lot of kids for some reason those will come in that way. It's just because they're not in simulation. Once they go ahead and hop over to simulation, then he'll look just fine. He'll look like this, and they can manipulate him. Otherwise, they can't move him. They can't do anything. So that's, again, if he looks like this when they bring it in, it's in online instead of simulation. Or offline. Is that what it is? No,
I think it's online. But I think, yeah.
No. I don't have that problem all the time. I had it once this year. The majority of them come in just fine. Why that kind of stuff happens, no, whatever. Okay, so right in the program, you have to teach the kids strategy. I don't know why once you show them, they refuse to do it, but you need to have these above positions. I need to be able to go directly linear to it. It has to do with momentum and things of the robot. It has to do with the weight and everything of the payload or the gripper, especially if you're trying to train them right now for these little black robots that they're going to use later on that are driven off of servos. If you just ask it to go to positions fast and then make it try to do something right after that without some kind of pause, he won't actually go to the position you asked him to. He'll bypass it and then try to work his way back to it as it will settle down. And these little black robots are really bad at it. To get any kind of accuracy, they need to have above positions that they can go to fast, and then slowly and accurately go straight down to where it is to pick these things up. Otherwise, they'll have no accuracy at all. So not only are you trying to teach them real-life strategy for the big robots, real-world robots, but it's mostly for these little tiny ones that they're going to use. They're awful. You'll ask them to stop somewhere, and you'll be going really fast, and they'll bypass it, and then the servo will back up and try to get it to where it was. But by that point, the kids already have their gripper closed, and they're trying to move somewhere else, and it's just a headache.
Keep in mind, too, that in industry, when you're picking stuff up, and they make robots to be very, very accurate. In order for them to be very, very accurate, you can't drag things across tables. You cause friction, and with friction, you build in inaccuracy. So hence, when programming for industry, you're always going to above positions and coming down, just straight down when you're doing pick and place operations. It's just the way it's done. So every time you program a position on the table, always program a position above it. You'll be all set.
So again, I don't show the kids this folder yet. All of these double letters, those are hot icons or hot keys that will make these things come up. The one that I want to show today is RE. RE will bring the mark tool up. So it's just like it was in CNC Motion. I'm going to do commenting. So if I just hit RE from E on the keyboard, I can go ahead and say that this is my manual pick and place. RE today is 3/1/2016. RE, whatever it is that you want. They can put all that information up at the top of their program, and as far as it's concerned, it just ignores that, just like a semicolon or your // in Robot C. It's just things that it ignores. So, very first two lines of program are going to be open gripper and go to position 99. So no matter how I turned off the robot, power outage, air, emergency switch, whatever, every time I turn on the robot, that's the first thing I want it to do. I want it to open its gripper, and I want it to go to position 99, and it's going to go to there fast at 100% speed. So you get to refer this to the students as your G00s and your G01s, and then we'll actually do 2s and 3s here in a minute if we have time. We'll see. All right, so open gripper, go to position 99. Right now you won't see anything happen other than he'll open his gripper because he's already sitting at 99. Okay, so then I'll go fast to position 10. I'll go linear to position 1, slow, 50% of its normal speed. I'll close my gripper. I'm going to go straight back up to position 10 at 50%. So you want the kids to think about 99 as anything that's not picking stuff up and putting stuff down, because really that's all this robot does. He picks stuff up and he puts stuff down. So those are going to be my linears at 50%. Everything else will be my go-tos. And these will all have a little bit of an arc to them rather than trying to bind the robot up and make straight lines. These are just for accuracy and placement. So 50% linears, all the rest of them will be go-tos and fast. Okay, so let's run what we've got so far. So I come up here, I can run one line at a time, I can run a full cycle, or I can loop it, which right now I wouldn't be able to do because that would just drop the cube. So I'll run it. So 99 fast, goes to position 10 fast, slow to 1, close the gripper, slow to 10, and then I can just keep writing the program from there. So I can say I want you to go to 20 fast, 2 slow, open the gripper, 2 slow, and then back to 99 fast. And so I will reset the cell, and we'll see what we've got. So for the most part, the kids kind of get used to the robot fairly fast. And the bad part will be later on when they've got lots of positions. Getting all those positions just sometimes takes a little bit of time. So we should open it up, and then you should go back to 99 fast. So that's an error right there. I did that on purpose. We'll say I did that on purpose because I forgot to go straight back up in the air. I just said go to 2, 50%. I said open gripper, then I said go back to 2 fast, or go to 2 again. So you can edit them. Just double click on them. You can edit them. If I had forgot that line of code completely, as long as I'm clicked on the line after it, I can then say insert it. It will insert lines of code. It will do all that for me. So now I can, even without this, I can go ahead and continue writing the program. So I can go back to 20 fast, go straight down to 2 slow, close the gripper, go straight back up to 20 slow, go over to 30 fast, straight back down to 3, open gripper, straight back up to 30, back to 99, and it's really helpful. There's a piece of paper that you can print that's in the curriculum to try to help the kids out, but knowing all these positions and where things out, it's really helpful for them to draw it out. Draw them a fancy little picture or something that has what it is and where all their positions and stuff are. Otherwise, right now I only have 6 positions. Once they start getting more than that, then it's going to start becoming really hard to keep track of all their different positions. And I can do whatever I want with him from there.
Keep in mind, too, that what Jim's doing right now is he's whipping through this. This is a great way, Jim. I think this is how I'm going to teach my kids the first day with the software and not do any of the actual activities. But as you go through the activities are step by step, A through E, F, G, probably about F, E and F. They're step by step, lockstep. A kid, an 8th grader, can sit down with that activity and complete the activity if they follow the directions. Jim's showing you that, look, this is what you can do. This is how you do it, and this is the step by step. So you're looking at it, you're saying, wow, he's moving pretty fast. How did he do that? How did that work? How does this work? In the first activity, this is basically 3 times harder than the first activity that they have you do, activity A. So it's all in there. And after they get through A, B, and C, they work on their own with these, and they figure them out, and they blow right through them. They're going to surprise you, I think. And they'll teach you guys something along the way as well.
Wherever you have the program highlighted, when you come up here to run the program, that's where it will run the program from. So if you're trying to run it from the beginning, then your kids will need to have it from the beginning. I do make it the habit of having them kind of break their program up with comments. So this first one can be my initial position. So up here I could have an RE home robots. Then down here it can be pick up from stock, whatever it is. If you really look at their example codes, I don't necessarily have them do it. The people that write the software do something kind of like this, so that it's kind of jumps out at you and shows you where these things are going to be. They don't typically do it for their first lines of code, that type of thing, but they'll do it for the rest of them just so that it kind of sits off to the side a little bit. And sometimes they'll even put one in here that has absolutely nothing in it, but those types of things, just so that you can start dividing the program. But otherwise, there's no way to put spaces in there. It's just being able to do this kind of thing. So you've got drop off 1, you've got drop off 2, you put back into storage, whatever it is. So like I said, the very first activity in the curriculum just asks them pick it up, bring it back, put it back down, go back to home, and that's it. So I go through this really quick to kind of get the kids unafraid of the robot so they can see that making movements and writing the program and all can be fairly fast, and then I just unleash them. So really, I only do about 10 minutes, and at the end of 10 minutes, I unleash them. So I do this demo, and then everybody makes that real quick. So I do about a 5-minute demo on this, they make it. Then I do about a 10-minute demo on this, and then they do it. And the next day when they come in, we do teach together. So we really do the first couple together. Me teach a little bit, them do it, me teach a little bit, them do it, and so on. And then after that, I just kind of give them the tutorials, and they just start kind of running with it. But this first part, they really need some help from you. They really need a little bit of advice on why am I picking these things up, what is it that it's doing. They need the explanation, not just run it into the program. So does anyone have questions about just manually manipulating the bot?
Hey, Nick,
Yep.
does the Intelitech machines, do they require you to home the resolvers at any point in time?
You home the machine.
Yes, every time you turn on the robot, you have a house up here. It's a little stick figure and a sun and a house, which is the most ridiculous icon they could ever come up with. For the physical robot, you have to reset the encoders to 0 every time you turn it on.
Okay, good. Because in industry, we obviously had to do that. Every time they went down and then they came back up, you would have to reset them. So
every time you close the software, you have to redo it. Because the controller box for the Intelitech is the brain, but it has no understanding of anything whatsoever. It's all in the software. So as soon as the software is shut down, it loses all of its encoder positions.
Okay, and then that makes sense because the same thing happens if, like, a control cabinet shut down, but you still had power to the robot or something in industry. It would be the same way. Or if your master computer shut down or your PLC shut down, it would do the same thing. You'd have to reset those home positions. I just didn't know if this actually did the same thing. I have a little different setup. I have 3 industrial robots that actually sit in my cell. They're huge. 4,700 pounds, 8 feet tall.
Wow.
Yeah.
Next big thing is, as a teacher, how are we going to have them turn all this in? I wish there was a fast forward button, and I wish there was an undo button. There's not. There is no undo button in this entire software. If you accidentally overwrite a position, it's overwritten. You got to go back and get it again.
Hey,
so there is no fast forward. He runs in real time, and there is no undo.
show them the show them the Pez dispenser, Jim.
Yes. Okay. So how I have my kids turn it in, they will turn this into me. They will turn in positions. They will give me this, and it shows me right now that these are all just manually done because they're all wonky. I don't have any positions there that are anything that's exact. So none of these positions were taught. And then I'll show you the little chiclets that he drops off. So I'm going to have this robot show and leave pads of what it is that it's doing. So I'll reset my cell, and this time I've got this little blue robot. It's called Show Pads. And when I have that on and run the program, I'll actually leave these little chiclets behind him, and they can get me a screen capture of this that will show me that this was a go linear. I can see that on their screen. That's perfectly straight up and down. I can see that that one that has a little arc to it, that's my go-to position. The problem is, and I don't think I'm going to use enough of them, he'll actually run out. I don't know if he only has 180 of them or whatever he has, but one way or another he has only so many chiclets, and then he'll erase them all and he'll start all over again. So some paths that are just reproducing the exact same path, I'll have the kids turn it off, because right now I can turn off the paths, not going to drop any more of them, and all he's doing is repeating something that already exists. So they'll show me this. I can see their linears. The only thing I can't see is speeds, and I can see that in their program. I can see all their fasts. I can see all their go 50%. I can see all that in the program. So they would get this in a good view and send me a screen capture of that. Questions? Okay. We'll go through this next one. This one should actually go really fast because I'm going to teach. So I need to know where my block is. My block right now is sitting at 300, 0. So that's a position that I want to know. So I'm actually going to, I'll save this project. Nice part is I can say a whole new project, and I can reuse that same cell that I've already developed. So I can use that cell as many times as I want. All right, so I'll go to my window, simulate and teach. Save my user screen. All right, so now instead of the whole headache of manually moving around, I'm going to expand this box, and now I can physically teach it. I wish when you expanded it that these icons kind of went away, because kids will write things up in this box, and then they'll hit this record position. All the record does is look at each one of the encoders and grabs a snapshot of whatever has happened to the encoders from the last time that it was recorded and puts those numbers in. Teach physically grabs specific positions. The other thing that you have is you have this little go-to object. So this little green one here, I can send the robot specifically to an object that I can record as a position. Kids are like, wow, I wish it was that easy in real life. Some of the robots are. Some of them have vision systems and whatnot on them, so they can do a lot of this now in real life. But regardless, there's my one. I can record that. And then I can say get position. So if I've got 1 typed in here and I say get position, it'll tell me what 1 is. Okay, so it was 300, it was 10 up in the air, it's a negative 90. So now I could say, what if I left X alone and I went up in the air? The block is 40 tall, so let's say 50 in the air, position 10, and I can teach that. And let's see what it does. So I'm going to close my gripper and I will say, go to position 10. If I don't like that, I want 60 up in the air, I can teach right over the top of it, and I can test it again. So now what I would like is like it to just go straight back and then straight down again. So straight back, how about this time to 200? And that's going to be my 20, not record, teach, and then 2 is going to be back to that 10 again. So let's say, let's see what 20 looks like. Go there. That's good. Let's see what 2 looks like. Go there. And that's all the second program asks them to do. So it asks them to physically teach the positions instead of record the positions. And then it really is no different. So I can just come in here, I can say open gripper, go to, I don't have a 99 yet. Reset. So 99 record. So go to 99 fast, and then go to 10 fast, and then go to linear 1 slow, close gripper, go back up to 10 slow, go comfortably to 20 fast, go down to 2 slow, open the gripper, go back up to 20 slow, go back to 99 fast. So this is what the second program just asked them to do. It asked them to go down here, it asked them to pick up the cube, bring it straight back to them, and put it right back down again. That's it. So again, you can turn on your chiclets, you can get your little view. And now when I go to my positions, you can actually see that each one of these has a coordinate system that's something that's more, so 200, 60, negative 90, and so on. So I can see they're not just random positions like they were before. So teaching just gives you the ability to give it specific coordinates to tell it to go there. But the 5 minutes that I have left, I want to help you out with relative. Whoever wrote the original relative program, it's really kind of a pain in the butt. It's harder than I really want most of my kids to ever write programming. They're doing relative to currents and all these kinds of things, and when all of a sudden my students get done with that, they're like, wow, I hate relative. It's really helpful if you use it for the right things, like position 1 compared to position 10, position 2 compared to position 20. Those should always be relatives. Those are positions that I can be in specific places. So if I say expand position 2, get position, no, position 20. So position 20, I'm going to make this a 0, this is 0, and this is 0, and this a 50, I can say position 20 is relative to position 2. And if I teach that, no matter what happens to position 2, position 20 will be directly above it, 50 in the air. So I have my kids, once they get past this first teach, all of their hover positions become relative, it's not 30. So 10 is relative to 1 up in the air. So the idea isn't necessarily making it so much easier for this one, but if I ever come back in and move this cube, all I have to do is re-record that one position, and all the above positions will go with it. So you just got to make sure the kids will accidentally sometimes forget to remove the pitch, and they'll try to make it go a -90 compared to how it was, and then it's going to try to wrap over itself, and it says that's not possible. So you have to say zeros for everything that you don't want it to move on. So really all I have done was try to simplify the program and make my above positions relative to the positions below it. And if I ever want to go back up and 50 is not enough, then I can come back in position 10, 60, teach, position 20, get, 60, teach, and it has re-gotten those positions, and now there's 60 up in the air compared to the 10, so now they're up 70 in the air. So don't be hung up on the one activity that they've got. I can show you real quick. This is what theirs looks like for the relative. It's a really neat project. That's not relative. This doesn't have the dip tanks. So this is supposed to have 3 little boxes in front of it, and they're supposed to grab the cylinder, and they're supposed to dip it, and wait, and then dip it, and wait, and then dip it, and then wait, and then put the cylinder back. So it becomes a little bit cumbersome. It's just kind of, just don't let the kids get stuck on how much they hate relative from this one project. This is weird. It doesn't have the dip tanks. It says it, but it doesn't have them.
Huh.
That's weird. This is the one that's in the curriculum.
You know what? I bet the person who did the one in the curriculum didn't put the tanks into the cell. So it's just missing the tanks.
So it looks like this. So they're supposed to pick it up, they're supposed to bring it over, bring it back down. You have to think about the floor thickness of each one of these boxes and so on. As long as they follow it step by step and do exactly what it says to do, then it works really, really well.
Yeah, the thing
if they just kind of look at the pictures and think they know how to do it, then it goes really, really bad.
The thing that makes this so difficult if you don't read the directions is that they make everything relative to the original position on the table, so that you can move anything you want. If you move that one position, all you have to do is record one position and everything changes with it. So it's kind of cumbersome, and it's really overwhelming for a first project. But like Jim said, everything's there as long as you follow the directions. But I like Jim's way of doing it too, adding relative beforehand. And I bet if you did a simple project like that first, it would make this project a lot easier because they would understand the concept.
So this really becomes my 4th project.
Nice.
My first one is just the manual. My second one is the teach. My third one is kind of a hodgepodge of manual and teach with some relatives, just the up and down, and then I hand them this and I say, Olay, good luck, and if you need me, I'll be back here having a sandwich. And they go and they do all this. In reality, while my kids are doing all of this, this is when I'm CNC machining my containers. So once they go on to the tutorials, they're pretty much on their own, and they're pretty well self-guided after that. And then we can just go out and start running containers.
Yeah. And we're running a little low on time. So Jim, would you do me a favor? Would you just throw up the website, the solutions? So basically, we're going to meet again in 2 weeks. And in 2 weeks, you'll probably have done a bunch of these activities, or you'll be working on these with your students. Your students will have done a bunch of these activities. And in the meantime, you might end up with some questions on some different things. And we've tried to answer the different questions that you might have. The solutions are probably in here. And Jim has actually gone and recorded the first 4 activities without any voice to step-by-step directions. I wouldn't give this to the kids right up front, but if you have a kid who's fumbling around or having a hard time, this might be a solution, a little help to go and watch the video and do it step by step as the video goes through it. So they're there to help you, but like, how do I get all my windows back? Or my robot seems to run into itself. What do I do? All the solutions are there. If you just take a look through the solutions, you'll see some really short videos on, oh, that's why it's doing that, and that's how I fix it. And we've got a few more to make. And if you come up with any other questions along the way, please make sure that you email us, and we'll make sure that we address it, so that you can continue to move forward with this in your classroom too. Does anybody have any questions?
No, that was really, really helpful.
I think I'm going to make my computer break next week too, because this was awesome. I could just watch Jim do Robocell all day long. Hey, nice work, buddy. That was good. Anybody else have any questions? Excellent. Well, give it a shot. Play around. Have fun with it. And if you have any questions, let us know. And if not, we'll see you in 2 weeks.
I just got the CNC motion up on my computers, and apparently we have an expert mill, but apparently at some point someone requested the software for a bench mill instead.
Hello?